Okay, number 242. It is a portion of electrical supply extending from the generating station to substation or from substation to substation. This is transmission lines. Letter B. Number 243. It is a portion of electrical supply having low voltages extending from the substation to the various consumers. This is distribution lines. Number 244, the most common voltages for residential and industrial applications. Answer is 240 volts. Number 245, it is the overhead service conductors from the last pole or the aerial support to and including the splices, if any, connecting to the service entrance conductors at the building. Okay, that's the overhead service conductors. This is the service, and this is the service drop wire. Letter C. Number 246, it is the point of connection between the facilities of the serving utility and the premises. Wiring. So this is service. Okay, it is the point of connection. So if you're referring to point, this would be service point. Letter B. 247. If a slaughterhouse building is constructed near the public roads, what is the recommended vertical clearance of the entrance cup? So this is, okay, so the keyword right here is that it's near the public roads. So the vertical clearance is 5.49 meters. And this one, the ones I've showed you are, or they have a whole number of values, but this one probably is coming from the equivalent feet. The answer here is letter C. Number 248. The conductors from the service point to the service disconnecting means. So this is the service entrance conductors. And we have here our meter and another disconnecting means, right? So right here, what's inside here, so that's referred to as this is 248. This is letter D. Number 249, it's an instrument used by the electric company to measure and record electrical energy consumption. This is letter A. Number 250, an electric meter installed along the building at the property line, mall, or electric post. So this is outside, letter A. Number 251, service equipment usually consists of circuits, switches, and fuse, the ones right here, switches and fuse, and other accessories. So the answer here is all of the above. 252, it is a set of conductors between the service equipment and the final branch circuit overcurrent protection device. So from this to the final, right, let's say from this one to this, let's say this is our final. This is what you call feeder, or main feeder if there's still another protection device right here. So the answer for 252 is letter D. Number 253, it safeguards the circuit components from overheating when the current flowing through the circuit reaches an amperage that will cause an excessive or dangerous temperature rise in conductors. So this is letter C, overcurrent protection devices. Okay, so it's not just fuse or it's not just circuit breakers, but the general term is the overcurrent protection device. Number 254. It is a device designed to open and close a circuit by non-automatic means and to open the circuit automatically on a predetermined overcurrent without damage to itself when properly applied within its rating. So designed to open and close a circuit by non-automatic means, because you can actually manually switch on or switch off. This is a circuit breaker, letter B. Number 255, it refers to the cutting off or disconnection of the current supply, and this question refers to the circuit breakers. The word here is, or the answer here is trip. Number 256, a circuit breaker installed in hammer mill equipment is always tripping. What is or are the possible causes? Okay, so it's like if we have this hammer mill, right? This is our hammer mill, and let's say it is connected to some source, and it is equipped with circuit breakers. And the problem is it is always tripping. So let's check the answer. For letter A, there's no power source. Now if that's the case, then if there's no power source, then of course this actually wouldn't trip. Okay, so for letter B, the supply lines are open. If the supply lines are open, then of course this will not run. And if letter D, the load is removed, let's say you don't have a load, just an electric motor, then the electric motor will just run, provided that it is still within the range. So the answer here is letter C. There is an overloading. 257, any current in excess of the rated current of equipment or the ampacity of a conductor. This is overcurrent, letter A. Number 258, operation of equipment in excess of normal, a full load rating or of a conductor in excess of rated ampacity when it persists for sufficient length of time would cause damage or dangerous overheating. So again, let us read it again. Operation of equipment in excess of normal, full load rating. So this one refers to loads, full load ratings or of conductor in excess of rated ampacity. So this is a more general term. This is overload, letter B. Number 259, the circuit conductors between the final overcurrent device protecting the circuit and the outlets. This is letter A. Number 260, it is a branch circuit that supplies two or more receptacles or outlets for lighting and appliances, and this refers to portable appliances. This is letter A. Number 261, it is a branch circuit that supplies energy to one or more outlets to which appliances are to be connected and that has no permanently connected lighting fixtures that are not a part of an appliance. This is letter B. Number 262, it is a branch circuit that supplies only one utilization equipment. This is letter C. Number 263, typical wattage value for estimating lighting outlet in the schedule of load computations. Now you would notice in a building plan, the electrical sheet portion, right, that there's a schedule of load. So in that schedule of load, what is asked here is what's the wattage value for estimating the lighting outlet. Okay, so we know that we have let's say 20 watt bulbs or a 30 watt bulb or many values, right? Let's say 10 watts or 5 watts bulb. So even though we have those wattage values, in terms of computation, what we will use is 100 watts. So this is letter A. Number 264, typical wattage value for estimating convenience outlet load in the schedule of load computations. Is this problem refers to the computation of the convenience outlet, and the wattage is 180 watts. 265, so typical wire size for lighting outlets. in mm squared. This is 2.0. Okay, so just take note of the word typical, because there are, or there could be other situations that that doesn't um, doesn't fit this. So moving on, 266, typical wire size for convenience outlets is 3.5 mm squared, letter B. And for 267, typical maximum overcurrent protection ampere rating for 2.0 mm squared wire size, this is 15 amperes, letter A. And for 268, typical rating for 3.5, this is 20 amperes, letter B. And 269, which of the following is not true for a good practices in circuiting? The answer is this problem asks which of the following is not true. If for letter A, lighting and receptacle should not be combined in a circuit, this is true. For letter B, we shouldn't have all the lighting outlets in only one single branch circuit, so we have to separate the branches, so that when one branch fails, then we still have lightings. So the answer is letter B. Number 270, considered high voltages are those exceeding, letter C. 271, this is letter B. Okay, now moving on to our next topic next item, 272 to 273, and that regards to the voltage drop across the line. Okay, number 272. A pole in a farmstead has a source voltage of 230 volts and a source current of 8 amperes. The conductor used is a number 14 wire in the length of 200 feet. Calculate the total voltage drop of the two lines if the resistance is 2.58 ohms per 1000 feet. So the idea is that if we have this, let's say we have this source right here. Let's say this is our source, right? Okay, and we have this line, and we have our load side. Okay, this is our load side. So because of length, then of course there's going to be a significant reduction in the power or the voltage. So it says here that we have a 230 volt supplies and a source current of 8 amperes. And the conductor used is number 14 wire and a length of 200 feet. Okay, calculate the total voltage drop of the two lines if the resistance is 2.58 ohms per feet. So this resistance refers to the internal resistance in that wire. Okay, so we are asked to find the voltage drop of the two lines and the available voltage at the other end. So it's like, what is the voltage drop here, right? What's the V drop, and what is the voltage here? Okay, because since we know the length is the length would the length will have a resistance, a significant resistance. Then instead of having 230 volts, we have here probably something less than 230. Let's say 200 volts or 220 volts. Okay, so if this is 230, this is 220, let's say, then what's going to be the drop here? So probably that should be 8 volts. Okay, so but how do we compute this? Okay, so recall our Ohm's law that V is equal to IR, and our R value is 2.58 ohms per 1,000 feet, right? Okay, times our total length of 200 feet. times 200 feet. This is equal to 4.16 volts per line, right? Per line, because this is one length, that is 200. So this is 4.16 volts per line. But if we have two hot wires, so this is or we need to multiply this by 2. So our total would be 4.16 times 2. This would be 8.32 volts. Okay, so voltage drop on two lines is 8.32 volts. This is letter B. And for 273, what is the available voltage at the end? So V end is just simply V source minus V drop across the lines. So we have 230 minus 8.32. The answer is 231.6 or something. Then this is letter B. Okay. We'll go back to our lecture discussions about the building electrical devices. Okay, let's continue now our lecture discussion, and we are now in building wiring and devices. For the contents, we have these different components or different electrical devices, and the first one is also the conductors, and we will discuss each one of them in detail. Okay, so let's start with conductors. A conductor, they are a material or electrical component that conveys or allow the flow of electric current from the or let's draw it here. So for example, we have this source and we have this load right here. So how do you get the current to flow from the source to the load? Is by the use of electrical conductors. Okay, so we have here the different types of conductors. We have wires, or we can have cables. Okay, and when we say wires, they are a type of conductors that has less than 8 mm squared in size. And when we say cables, they're simply conductors that are greater than 8 mm squared in size. Okay, and furthermore, this wire is further classified in terms of solid or stranded. And right here in our figure, we have here the solid and the stranded wires. And when we say stranded wires, it's just simply a twisted wire to form a metallic string. So in the figure, we can see here that a solid wire is simply this material, this copper material. It's a one solid wire, whereas in stranded wires, it's composed of small little wires that are just twisted. Okay, and the main advantage or the typical advantage of stranded wires is that it's more flexible than solid wires. Okay, next one is that we know that wire comes in different sizes, and the common specification for wires is in terms of AWG number and the metric system in mm squared or in mm. Okay, and we have here in the figure, we have a small wire here, and we have the biggest wire right here. And intuitively, if you have a smaller wire cross section, then the capacity of the conductor is less, and if you have a larger cross section, then the capacity is greater, and that capacity about being able to carry the current is called the ampacity. Okay, so we have here AWG number, that stands for American wire gauge, and the mm squared in terms of the metric specifications. And right here we have this gauge 14, gauge 12, gauge 10, gauge 8, and gauge 6, and so on. And here I have written the equivalent, although it may not be totally exact, but the approximate equivalent is that for gauge 14 it's 2.0 mm squared, and for gauge 12 that's 3.5 mm squared, and for gauge 10 that's 5.5, and this one is 8.8 or 8.0. Okay, and right here there's an information regarding the capacity in terms of numbers. Let's say here it says 15 amps or 20 amps or 30 amps and so on, and also the applications. Like for example, if the application is for general lightings and receptacle circuits, then this is the typical wire size. And if you have some appliances, increased loads, then you have this probably gauge 12, and a much higher loads would mean maybe to use gauge 10, and for feeder wires and large appliance wires that's gauge 8. Okay, so let's have some detailed discussion regarding this, the size of wire. And we have in terms of the English systems, and we have also the metric systems. And we can describe the wire in terms of linear or in terms of area. And in linear, we know that the unit is simply in mm, and for the area that's mm squared. But in the English units, the linear usually is in terms of mil. In terms of mil, and that 1 mil is equal to 0.001 inch, or 1 over 1,000 of an inch. Okay, so because the wires, they're actually smaller than 1 inch, so probably that's why we have these units. Okay, so right here, if this is our wire cross section, then that 1 mil could be this length. And in terms of area, we can have a circular mil or a square mil. And for circular mil, basically it's just the square of the diameter, or area in terms of circle. And when we talk about square mil, then that's the area of a square. Okay, and we can see here in the figure that square mil is larger than the circular mil, and the difference is this shaded area, this blue area. And we also have this conversion factors. Okay, so some type code of thermoplastic insulations. We have said that, by the way, I forgot to discuss this one. I forgot to discuss that when we say cord, that refers to a heavily insulated wire. Okay, so heavily insulated wire. So if this is our wire, this is our insulation. Okay, so if this is our wire, right? If this is our wire, this will be our insulation. and we have, or there's a lot of materials used for an insulation, but right here I'll just focus on the thermoplastic insulations. And you would notice that in the label of the wire or the conductors, that sometimes you see THW or THHN or TW, and you might wonder, what does that mean? Okay, so we have here the symbols, like for example T, that stands for thermoplastics, and if it's H, then that stands for heat resistance, and if it is W, then that's moisture resistance, and we also have M if it's oil resistance. Okay, and a lot more symbols probably. So right here I've only included some few, actually only 3. And if we see, okay, so right here, right, these are our cable markings, and if it is THW, then that simply means that it's moisture and heat resistant thermoplastic. And for THHN, that's a thermoplastic heat resistance, and TW, thermoplastic moisture resistance. Okay, so that depends upon the applications or exposures. I mean, if where you want to expose this conductor, is the surrounding or is the environment has a high moisture, or is it going to be exposed to a high temperature or something? So those are the applications of this different types. Okay, and also right here we can also see the markings, the voltages, okay, and many other informations. Okay, let's move on now to our next electrical device. That's the raceways. And raceways are channels or wiring accessories so designed for holding wires, cables, or bus bars that are either made of metal, plastic, or any insulating medium. So right here in our figure, we have our conduits. This is our conductors, right? And we have our raceways, and specifically this type of raceway is a conduit. And we also have connectors and also clamps. Okay, so these raceways can be classified, or a common classification is in terms of a conduit or cable trays. Okay, so right here we have a comparison between a conduit. This is a conduit, and this one is a cable tray, and they are all used for routing and protection of wires. But we'll only focus in these conduits. Okay, so conduits, they're a type of raceways, and the function is that they are for protection. They protect wires, okay, from external damage, or it's also possible to, or I mean, one function is that if there is a fault, if there is a fault in the wiring, then it can protect, it can provide protection for the occupants. Okay, so if the problem is inside, then of course the occupants or the building would be safe. And if the problem is outside or external to the wirings, then of course it can. The function is that it gives protection to the wirings. Okay, and also it provides a grounded enclosures and also for routing. Now for the conduits, we have it can be classified in terms of either rigid or flexible. Okay, so if it's flexible, then of course it has some degrees of freedom or something. And in terms of materials, it can be metal or non-metal. Okay, and right here we have different types, common types of conduits. We have EMT, RMC, PVC, and these two. So let's start with this RMC. This RMC means rigid metal conduit. Okay, so it's something like a pipe used for flexible. Okay, so if it's flexible, then of course it has some degrees of freedom or something. And in terms of materials, it can be metal or non-metal. Okay, and right here we have different types, common types of conduits. We have EMT, RMC, PVC, and these two. So let's start with this RMC. This RMC means rigid metal conduit. Okay, so it's something like a pipe used for water supply, except that this is designed or tailored for electrical constructions or electrical applications. Okay, so when we say RMC, the characteristic of that is it has this threaded ends. As you would notice, it has threaded ends, plus the wall is thicker, which means, of course, it means higher cost, but the protection is maximum also. Okay, and a lower version or a lighter version of this RMC is called IMC, or intermediate metal conduit. Okay, another one is this EMT. That's electric metallic or metal tubing, metal tubing. Okay, so I guess that's electrical or electric metallic tubing. This type of conduit is, as you can see, it's a non-threaded, and of course the accessories would be also without threads, and it is lighter weight. Another common conduit is the PVC, which can be rigid or flexible. And in terms of color, the ones that's the ones that's most common is the orange ones. Okay, for electrical applications. Okay, so intuitively we know that using PVC or plastics, in terms of cost, that would be less cost than its metallic counterparts. But of course, in terms of protection, let's say in temperature ranges, then of course these metal conduits, they can provide more protection than this PVC for much higher temperatures. Again, right here we have FMC. That's simply flexible metallic conduit. Because of these helical wounds or spiral wounds, then it can provide some flexibility in maybe in turning or routing. And we also have here LFMC, which is simply stands for liquid tight. Okay, so liquid tight flexible metallic conduit. Okay, moving on now, let's talk about boxes and enclosures. And when we say boxes and enclosures, they are used to protect electrical connections or for mounting other electrical devices such as switches and outlets. And we have typical shapes: square, rectangular, octagonal, and round. Okay, next one, let's talk about switches. Now, switches are devices that opens or close the circuit. So if we have our source right here, and this is our switch, and then this is our, let's say, our load. Okay, so once this switch closes, then it can provide power to the load, and if it opens, then there's gonna be no electricity that's flowing in the circuit. Okay, and when we talk about switches, these terms pull and throw, they come into play, and we'll talk about that in detail. So when we say pull, that refers to the number of closed independent circuit. Again, the pole refers to the number of closed independent circuit, and the word throw is the number of positions in which a given pole is closed. So right here we have SPST switch, and that stands for single pole, single throw. Okay, so in terms of pole, the number of closed independent circuit. Okay, so if this is our switch, then if it closes, then how many closed independent circuits does this switch has? It has only one, right? So once it closes, it has only one. It has only one closed independent circuit. So that is why this is just a single pole. And in terms of throw, it is the number of positions in which a given pole is closed. Okay, so how many positions? It has only one position. And right here we have SPDT, and that stands for single pole, double throw. Okay, so we have here our switch, so it can switch either here or either in this circuit or this circuits. Okay, but in terms of pole, it says here that it refers to the number of closed independent circuits. So if it is switched to this terminal, then of course you'll only have one independent circuit. And if this switch is right here, then of course the number of closed independent circuit is only one. So that's just single pole. But in terms of throw, okay, this is the number of positions in which a given pole is closed. So either either in this terminal or this terminal, it is still a closed circuit. So that's why that's single pole, double throw. And right here we have the double pole single throw, and this one is double pole double throw. Okay, so double pole is simply because there are two closed independent circuits. So this is our circuit number 1, this is circuit number 2. And in terms of throw, it's just a single throw. Okay, whereas this one, double pole double throw, you can have a two position for a closed circuit. Okay, so we can say that SPST is just simply a typical on-off switch, and this one can be said as this is still an on, except that this has probably a low and high. Okay, so for example, we have a fan. So if this is our fan, right, if this is our fan, if we only have if we have a switch, or if we install a switch that's just SPST, that just means it just on or off, right? And if you install this SPDT, that means that we can have a switch that can work either low, that can work on low and high. So this is still on, this is still on, except that the speed is low, and right here the speed is high. Okay, and if you have and for this ones, then probably you have a circuit for heating, say for heating, and then also for fan, then that's probably the application of this DP double pole switches. Okay, so right here we have here a single pole switch. And we have here a single pole double throw switch, and also referred to as three-way switch. Okay, so for a single pole, if this is our load side, this is our source, and then this is our load. Then if we install it something like this, so that's the typical on and off. But for this one, for the three-way switch, now we have a switch right here, right, and we have another switch. So this application of the three-way switch, these two three-way switch, they are actually used in, or the most common application is along the staircase. Okay, so example, you're here and you want to turn on the lights. So of course you need a switch right here. You need to turn on, and then you go up. And of course, in order to turn off this light, you don't need to go down. So that's why you have to install another switch right here. Okay, so that's gonna be this SPDT. And we also have a four-way switch. Okay, now let's move on. Let's talk about outlet and receptacles. An outlet is a point in the wiring system at which current is taken to supply utilization equipment, or in simple term, it's any point that supplies an electrical load. So we have types right here. We have convenience outlet, we have lighting outlets, and receptacle outlets. Okay, so if you have an equipment, for example, an electric motor, or let's just say a small electric motor. Okay, and you insert the plug right here. Okay, so that energizes the electric motor. Okay, and for lighting outlets, that's intended specifically for lights, and we also have these receptacle outlets. Okay, now let's talk about lamps. Lamps basically are a source of artificial lighting, and there are actually many types of lamps, but for agricultural lighting applications, we have this listed. We have the incandescent lamp. We also have the fluorescent lamps, low pressure sodiums. We also have high intensity discharge, or HID. And right here in our figure, we have this an example right here. This is an incandescent lamp, and this one is a fluorescent lamp, and this one is high intensity discharge lamp. And this one is I think this is just an LED lamp. Okay, so now let's go to the review questions. Okay, number 274. Conductor sizes are specified in terms of blank. Okay, the answer here is we only discussed the 𝐴WG number and mm², but also there are still many ways to specify, like for example in terms of diameter, or in terms of circular meal and things like that. So the answer here is letter D. Next, number 275. The higher the 𝐴WG number, the blank the wire. So we have here, if you recall in our lecture that for example we have a gauge number 14, and you compare that to gauge number 10, for example. So right here we have the smallest size, and right here we have a larger size. Okay, so when you say higher, the higher the 𝐴WG number, that means that we have a thinner wire. This is letter B. Number 276. They are electrical conductors 8 mm² and smaller in sizes. This is wire. Letter A. Next, number 277. They are electrical conductors larger than 8 mm². Their referred to as cables. 278. It is a conductor consists of wires twisted to form a metallic string. This is stranded wire, letter C. 279. It is the term given to an insulated stranded wire. Okay, this is I think this should be a heavily insulated stranded wire. This is what we call cord, letter A. Okay, 280. Ordinary conductor wires for buildings is normally rated at 300 or 600 volts. 281, which of the following gives the nearest value to 𝐴WG number 14? This is 2.0. This is letter A. 282, which of the following gives the nearest value to 𝐴WG number 12? Okay, so this one is 3.5 mm squared. Okay, so this is letter B. 283. Which of the following gives the nearest value to 𝐴WG number 10? This is 5.5 mm squared, letter C. Next number. What are the common informations that can be seen in the conductor or cable markings? Okay, so we can see the maximum rated voltage. We can also see the size. We can also see the manufacturer's name and the proper designation for the type of cable or wire. So the answer here is letter E. Okay, next number 285. A wire with the letter type THW has a trade name of. Okay, so recall that H that stands for heat resistant, and W is moisture resistant, and for T stands for thermoplastics. So therefore this one is letter B. Next number 286. A wire with the letter type THHN has a trade name of thermoplastic heat resistant. 287. A wire with a letter type TW has a trade name of thermoplastic moisture resistant only. So this is letter D. Next number 288. It is defined as the ability of the wire or conductor to carry current without overheating. This is ampacity. Okay, so again, the definition of ampacity is that it is the ability of the wire or conductor to carry current without overheating. Okay, 289. In practice, the conductor ampacity is blank if it is in open air compared to when it is in a raceway. So what this means is that if you compare a conductor, let's say we have this conductor and we have another conductor, but this one it's enclosed in a raceway or conduit. So it says here that the conductor capacity is blank if it is in open air compared to when it is in a raceway. So we have a higher ampacity if it is in an open air. So the answer here is letter B. Next, number 290. The ampacity of a conductor increases as the size of the conductor increases. This is true. Next, number 291. An enclosed channel of metal or non-metallic materials designed expressly for holding wires, cables, or bus bars. This is called a raceway, letter C. Okay, next number. It is the most common electrical raceways used in all types of constructions with respect to the type of materials used. Okay, so for a raceway, we can have conduits, we can also have cable trays, something like this. If it's just something like a tray, then that's just a cable tray. But if it's enclosed ones, like this one, this is a conduit. The most common ones are letter C. Okay, 293 common types of electrical conduits. We can have rigid metals, flexible metals. We can have rigid PVC, or we can also have a flexible PVC. So the answer here is letter E. 294, it is a type of conduit of circular cross-section made of helically wound formed interlocked metals strip. Okay, so because of this helical geometry, then it becomes flexible. So this one is FMC, letter A. 295, a 15 mm rigid metal conduit is used for the wirings of a bag storage warehouse. The conduit is supported by a series of steel clamps spaced at a distance. What is the maximum spacing allowable? Okay, so what this means is that, okay, so we have this wire inside a conduit, okay, and this is being supported by clamps, okay, and the question says what's the maximum distance. Okay, so what is this distance between clamps? And for rigid metal, the maximum spacing is 3 meters. But for non-metallic, rigid non-metallic conduit, we have a maximum spacing of 0.9 meters. And of course, you can think about it that if you have a rigid metal, then of course the flexural resistance is greater as compared to non-metallic conduits. So the answer for 295 is letter C. For 296, this is letter B. And for 297, the answer is all of the above, letter D. Okay, next item, 298. It is used in close wiring connections for a number of applications like switches, fixtures, and others to protect them. So this is electrical boxes, letter B. Next number, 299. It is the box commonly used for switches and outlets. Okay, the term right here is utility box. Okay, so we have a box that looks something like this. Okay. And we also have this octagonal box. Okay, so this one is is referred to as utility box. So 299 is letter A. Number 300. What is the shape of the box commonly used as junction box? Okay, so commonly used, the octagonal, letter C. Number 301. Which of the following installations are electrical boxes being installed? So what this says is we can install this mounted on wall surface. So this is our wall, and let's say this is our electrical box, and this is our conduit. Okay, so this is our wall, so it can be mounted on the wall. It can also be something like this, behind the walls and in recesses. Okay, so this is our wall. Okay, or it can also be on the ceiling. So this is letter D. Next, number 302. It is a box with blank cover that is inserted in one or more runs or raceway to facilitate pulling in the conductors. So once you see this keyword, pulling in the conductors, this is letter D. Number 303. It is a box. It is a box wherein the protective devices are grouped from which they are fed. Okay, so protective devices. This refers to the circuit breakers. Okay, so we have this box and we have a lot of circuit breakers. Okay, so this is letter C. Next, number 304, which should fall is not true when installing a panel board. Letter A, it must be placed in an accessible location. Letter B, it must be installed near the load center. Letter C, it must be located where the branch circuit exceeds 35 meters long. Letter D, none of the above. Okay, so right here it says which of the following is not true. The answer here is it must be located where the branch circuit exceeds 35 meters long. This is letter C. Okay, next number 305. It is an outlet intended for direct connection of a lamp holder, a luminaire, or a pendant cord terminating in a lamp holder. So this is a lighting outlet. Okay, number 306. It is a device that by insertion into a receptacle establishes connection between the conductor or the flexible cord and the contactors connected permanently to the receptacle. This is letter B. Okay, next, number 307. It is an outlet where one or more receptacles are installed. So this is letter C. For 308, when mounting a wall convenience outlet, what should be the distance from the finished floor line? Okay, so this is our FFL, or finished floor lines, and this is our wall. Then the distance must be, right? Actually, I'm not sure if the distance is based here or along the center line of the sockets. Okay, but the safe one would be at least at the bottom of this geometry. Okay, so right here we have 30 to 45 cm. This is letter A. 309, in areas like farm shops, the mounting height of the receptacle is 105 to 110 cm. This is letter C. Okay, number 310. Electrical outlets are rated in amperes. Letter A. Okay, actually, you can also think about it that when we compute for the loads or when we size the wires and the protection devices such as the circuit breakers, it's actually being based on these amperes. Okay, so moving on, 311. When mounting a wall convenience outlet, what should be the distance from the finished floor line? This is just the same. This is letter A. 312. It is a device that open or close the circuitry in an electric circuits. This is letter B. And number 313 is the most commonly used switch to control a light receptacle or other device from a single location. This is letter A. Okay, and for 314, how many terminals does a single pole switch have? This is letter A. Okay, so you can also refer back to our lecture. Okay, next number 315. It is a type of switch commonly used in industrial applications and having 4 terminals instead of 2. This is a double pole switch. Letter B. Okay, next item 316. The number of terminals of a 2-pole switch has 2-pole or double pole. So this is letter C. Number 317. Type of switch used in pairs and allow you to control a light or receptacle from 2 different locations. This is letter C, the 3-way switch. Number 318. How many terminals a 3-way switch has? Okay, so this is a double throw. We have letter letter B. Okay, next, number 319 is the type of switch used in between a pair of three-way switch to provide control from three or more different locations. This is four-way switch. Number 320, common ratings for single pole switches. It's 15 amperes or 20. So the answer is letter B. Number 321 is the type of switch used in between a pair of three-way switches to provide control from three or more different locations. This is letter D. 322, type of electrical outlet with three prongs. This is letter A. For 323, this is ungrounded, letter B. And for 324, which of the following is mostly used type of an electrical outlet? This is a duplex. Okay, so this is a set of our outlet, and we have one here and we have another one, so that's what we call a duplex. Okay, this is letter B. Okay, next, number 325. The type of lamp are critically dependent on the wattage supplied, that even for a small fluctuation of the current, its life output and efficiency is materially affected. So this is okay, this is letter A, incandescent. Okay, dependent on the wattage supply. Okay, next, number 326. These are electrical devices designed to hold and connect the lamps to power supply. This is letter C. For 327, it's a part of lamp. This is necessary for start up and thereafter to control the arc. Okay, it is a part of lamp that is necessary for startup and therefore to control the arc. This is letter A. Okay, that's the ballast. And number 328, with a fluorescent lamp. Okay, when a fluorescent lamp makes no starting effort. Okay, so let's say this is our lamp, and we have here our bulb, and right here we have we have a device right here called the starter, and we have here, right, that's our ballast. Okay, so for number 328, when a fluorescent lamp makes no starting effort, what are the possible cause? So we can have a defective balance or lamp not making proper contacts. So right here, sometimes if there's some loose connections right here, sometimes it's not going to light up. And also for the starter, if it's loose, then it will not start up. So the answer right here is letter D. And number 329, a fluorescent lamp produces about blank more light per watt than does the incandescent. The answer here is 3 times, letter C. Okay, number 330. Heat lamps shall be placed blank above the floor or 152 mm above the sow. So this is our sow, for example. Okay, so we can have according to our past, the heat lamps can be if this is the sow, this would be 152 mm, or if based on the floor line, that would be 762 mm. So this is letter B. Okay, next, number 331. The type of lighting shall always be available for use during the night or darkened period of days for an agricultural building. This is artificial lighting. Number 332. What is the lighting requirement for the feeding area of dairy cattle housing? This is 200 lux, letter A. Next, number 333. Now, what is the lighting requirement for the pens of a dairy cattle housing? This is letter B. And 334. What is the lighting requirement for feed storage area of a dairy cattle housing? This is letter C. And for 335, you still have to check the given, so we'll just leave this for now. Okay, but if we want to really solve this, I guess we can obtain the answer by simply multiplying the length or the dimensions. So 20 by 60, that's 1,200 feet. Okay, and we multiply this by, or we have to convert this in terms of feet. Okay, so once you have this, I guess you can multiply that to the lux requirement, right? So the given lux, and then you divide this by the lumens. And what we get is 223.08 or 224. Okay, but again, I still have to check again the equations and the given. Okay, number 336. So number 336. In the small-scale poultry dressing or slaughtering plant, the convenience outlet shall be installed at blank above the finished floor line. This is letter C. Okay, next, number 337. According to PAS 422-1, branch circuit conductors that supply a single motor used in a continuous duty application shall be an ampere rating of not less than 125% of the motor's full load current rating. Number 338, pipe color for electrical lines according to PAS 422-1. This is letter C. Number 339, the specified branch circuit ampere rating for lighting and other utilization equipment according to PAS 42. Okay, so for lighting and other utilization equipment, this is 15 to 20 amperes. This is letter A. And for 340, the minimum branch circuit ampere rating for other non-lighting equipment and convenience outlets according to PAS 42-2. Here, this is 50 amperes. This is letter D. Next, our last item, 341. The minimum headroom of working spaces for service equipment, switchboards, panel boards, or motor control centers according to PAS 42. The minimum headroom is letter A. We are now done in this review course in agricultural electrification and controls. I hope you've learned a lot, but I know that there are still some more topics that we haven't discussed, like, for example, the electrical load center, how to compute the electrical load center, and the topics on motor slips. Okay, so I think I just have to include that in our, or in the next year review. Okay, so that's all, and God bless in your exams.
Meron pa ba kayong mga questions?
Alright, now we'll start our question and answers for the gears. Number 194. A drive its shafts are operating on a counterclockwise direction. So the answer is gears. Based on the choices, it's only the gears that has this condition. Number 195. Gears are used for agricultural machinery because blank. Letter A, they are expensive and durable. Letter B, they transmit high power and efficiency and with long service life. Letter C, they have low operating and maintenance cost. Letter D, none of the above. The answer is letter B. They transmit high power and efficiency and with long service life as compared to other the power transmission drives such as the belts and the chain and sprockets. The letter C is they have low operating and maintenance cost. Probably the cost would be on the lubrications and of course alignment issues. So the best answer is letter B. Number 196, AGMA stands for, that's the American Gear Manufacturers Association. That's letter C. Number 197, it is the most common type of gear used in agricultural machinery with straight and parallel teeth to the shaft axis. So the keyword here is straight and parallel teeth to the shaft axis. The answer therefore is spur gears. Number 198, it is a type of gear commonly used non-parallel and non-intersecting shafts, usually found in gear reducers or gear motors. A keyword right here is that non-parallel and non-intersecting. So if this is our worm gear, and then this is our let's say this is our spur gear, we see that the axis is, they're not parallel but also they're not intersecting as compared to the bevel gears. So for bevel gears, they're actually intersecting because it's something like this. Although this one is non-parallel, but the shaft axis is intersecting. So for 198, the answer is letter A. Next, 199, it's a type of gear used for intersecting shafts, usually at right angles. The answer is bevel gear, letter C. Number 200. It is a straight rod that meshes with pinion and is used to convert rotational motion to linear motion. So if I draw it here, let's say this is my pinion or spur gear. Actually, the term pinion only refers to the smallest, let's say the smallest gear between two gears, and that's just a spur gear. So if this is our pinion or spur gear, then we have another gears right here. So if this one rotates, then this action is linear. So from rotational motion to linear motion, and we call this one as gear rock. This is our pinion, simply spur gear. So number 200, the answer is letter A. Number 201, it is a type of bevel gear with speed ratio of 1 and is used only to change the direction of power transmission. So if the gear ratio is just 1, then it just simply means that they have the same speed and that's the same torque, but the intention is to only change the direction, then that's the meter gear, letter C. Number 202, it is the distance between similar equally spaced tooth surfaces along a given line or curve. The answer is pitch. Number 203, it is the distance from the tip of the gear to the pitch circle. This is our gear tooth, and we know that this is the pitch circle, and the tip of the gear, or the top portion of the tooth, then this distance is called addendum, and the distance from the pitch circle to the root circle, that's called dedendum. So the answer for number 203 is letter A. Number 204, it is the distance from the pitch circle to the root circle. That is the dedendum, letter B. Number 205, which of the following circles is the largest? Then if this is our dedendum circle, this is our pitch circle, then this one would be the largest, and that's the addendum circle. So 205, the answer is letter A. 206, the answer is letter B. Number 207, it is a common unit of size for a gear. The answer is letter C. Okay, next number 208. What is the gear ratio of the drive if the number of teeth of the driving gear is 40 teeth while the pinion gear is 30 teeth? So recall in our lecture that when we talk about gear ratio, we are talking about the ratio of the teeth, and therefore this will be the ratio of this should be the ratio of the driving gear to the driven gear. Let's write it here: 40 teeth divided by 30, and we get a value of 1.3. So the answer is letter B. 209. Calculate the speed ratio if the speed of the driving gear is 200. Okay, so when we talk about speed ratio, recall that we are talking about the angular velocity. So since we have the teeth and we have the and we have the RPM, then we can use this relation N1 T1 is equal to N2 T2. And the driving gear has 40 teeth, and this one, the N2, and that's what we're finding. T2 is 30, and what's given is the speed of the driving gear, which is 200. So therefore, N sub 2 is equal to 200. I think 267. This is 267. Okay, but what we're asked is the speed ratio. So speed ratio is just simply the speed of the driver, N1 all over N2. Now N1 is 200 and N2 is 267. The answer is 0.75. So the answer for 209 is letter C. The next item, 210. Determine the number of teeth of the driving gear of a spur gear drive if the speed ratio is 0.8 and the driving gear teeth of 48. Okay, so what's given is the speed ratio and the teeth of the driving gear, and we have to find the number of teeth of the driving gear. Okay, so let's write down the equation first for the speed ratio. NR is just equal to N1 all over N2. So therefore 0.8 N2 is equal to N1. Okay, now let's try to apply the speed and teeth relation. N1 T1 is equal to N2 T2. Now let's substitute this N1 with this value, which is equal to 0.8 N2, right, times T1 is equal to N2 times T2. Now since we have the same N2 on both sides, then this is just equal to 1. So therefore, if we simplify, it's just 0.8 times the number of teeth, is 48, is equal to T2. So T2 is equal to 45. That's 45 teeth. So the answer for 210 is letter C. Okay, in the next video, we'll start our lecture discussion for shafts, keys, and splines. This is our next topic for the review course in machine design for ABE. The title of this video presentation is about shaft, keys, splines, and couplings. For the contents, we'll first discuss the shafts, and then we'll move on to the shaft components, the keys and keyways, and the splines, the shaft couplings, and universal joints. Now, shafts are rotating members usually of circular cross-section. That's the typical cross-section that's used for shaft, used to transmit power and motion. It's a circular cross-section that's typical, but other cross-sections are also possible. Now, it provides the axis of rotation or oscillation, or elements such as gears, pulleys, flywheels, cranks, sprockets, and the like, and controls the geometry of their motions. Right here in our figure, this is a photo taken from a rice mill equipment, and we have an eccentric shaft. We have the shaft right here, and there is an eccentricity that this eccentric shaft portion right here is connected to this oscillator. So this oscillator moves back and forth, so something like it's a linear, although not really, not perfectly linear motion, but somehow it induces this linear motion from shaft rotations. So the shaft actually looks like this. So this one is has the bigger cross section, and there is a shaft right here, and it's one solid piece. It's being machined, so it's one solid piece. And because if this is the center of the shaft, then this small portion, or this eccentric shaft, is actually somewhere right here. And therefore, as this rotates, then there's gonna be a something like an oscillation of this assembly. Some shaft terminologies are, I think you have also heard a lot of terms regarding the shaft. For example, the gear counter shaft. So basically, it's just a gear with, it is a shaft with just gears. And for example, the camshaft, it's just a shaft with cams. And the cross section for camshaft is something like this. So this is your shaft, for example, and then there's a cam. So the cam has to be connected to some followers. And this one, the crankshaft, is actually found in the engine. So as the piston goes up and down, there's actually a change of motion from the linear action of the piston into a rotational motion. Okay, so right here would be the crankshaft. And from this crankshaft, it is some portion is connected to a shaft above the piston, and this shaft actually controls the opening of the valves. And this shaft right here is the camshaft. Then other shafts are termed like, for example, spline shaft. So from the term itself, spline, just basically series of grooves around the shaft. So there's spline sections right here. And for a step shaft, you would notice that you have changes in cross section. Right here you have this diameter, but over here you have a smaller diameter, and another one right here would be a much smaller diameter. And so this one is machined or constructed this way because for specific, maybe for capacity, for let's say torque capacity, and also to position the bearings and the pulleys or gears and things like that. Okay, so that is why there is a shoulder right here. And we also have hex shaft because the cross section is a hexagonal cross section. So some shaft terminologies, we also hear about the line shaft. Basically just means that it's the main shaft, or it's the shaft connected to a prime mover. Okay, and then we have the counter shaft. That's an intermediate shaft between the line shaft and the driven machine. For example, we have an electric motor. So let's say we have this V-belt drive. right? And then let's say there is another reduction right here. And of course, if there's a shaft, then there's going to be bearings. And let's say this is our driven equipment. This is our driven equipment. This one is our prime mover. And based from the definition, a line shaft is a shaft connected to a prime mover. So therefore this will be our line shaft. Then this one will be our counter shaft or intermediate shaft. And we also have axle, which is a non-rotating member carrying no torque, which is usually found in the wheel assembly. And spindle shaft is simply a short shaft. Okay, so an example of this is the shaft of the electric motor itself. So it's just short. Sometimes it's referred to as a stub shaft. The point here is that there are a lot of terminologies regarding this shaft. And so for the shaft materials, the PAS has specified that for agricultural machines, we have to use the AISI 1020, cold rolled or stainless steel 304 or 316. So this 304 and 316, they are the series based on AISI designation. And here the AISI 1020 cold rolled. And now for the shaft keys and keyways. For the shaft keys and keyways, that's based on PAS 304. Keys are machine elements used to fasten shafts, pulleys, and other components with hub. Right here in our figure, we have a shaft, and it is being grooved here, and the groove refers to the keyway. Okay, so how would you fasten this shaft to the hub? And let's say this is the pulley, for example. So how would you fasten the pulley to the shaft? So you have to provide a groove on the shaft, and you have to provide a groove on the hub of the, let's say, of the pulley, and you have to insert the key. Okay, so therefore, keys are the machine elements used to fasten shafts, pulleys, and other components with hub. So both the shaft and the component must be machined with a keyway. There are many types of shaft keys. If you refer to PAS 304, there are many types of shaft keys, and the ones enumerated are this one: parallel, taper, and wood rough. When we say parallel, basically it's just it has longitudinal sides. I mean, it has a longitudinal sides where they're all parallel or square or something like rectangular. We also have taper, so that means that along the length we have something like this. So if you view that along the side view, we get something like this. So it's tapered, right? So it's tapered. And for wood raft, we have a semi-circular section. It's something like this. And for parallel keys, we can have both ends round, right? That's one example or one type. Then another type would have both ends rectangular or square, and we can have one end round. Now let's move on to splines. Splines can be described as series of axial keys machined into a shaft with corresponding grooves machined into the bore of the mating part. Okay, so for example, this is our shaft, and you would notice that it acts something like a key, but it is integral to the shaft itself. And therefore, if you have these splines, then you have to also make grooves on the hub or on the bore of the mating part. And in PAS, splines can be found in PAS 318, and we have two types. We have square and involute, which just refers to the profile of this tooth right here. Now, let's move on to shaft couplings. Shaft couplings, the term coupling refers to a device used to connect two shafts together at their ends for the purpose of transmitting the power. So for example, you have this prime mover, and it's an electric motor. Then how would you couple this this shaft to the let's say to the equipment, to this equipment? Okay, so the pump will also have its shaft, but in order to connect the two shafts together, you have to use what's called the coupling or shaft coupling. Basically, we can divide or we can classify the couplings in terms of rigid and flexible. And from the word itself, when I say rigid, it means that it has no relative motion, or we can use this rigid type coupling into equipment that requires precise precise alignment. So for example, for the electric motor, it has to be connected in a precise manner. Okay, so it must be really aligned, so otherwise there's going to be a malfunction of the equipment. But there are equipments as well that you need to accommodate some misalignments, and if that's the case, then what you need would be the flexible couplings. Okay, so flexible, it means that it can accommodate some misalignments. Let's talk about the types of shaft misalignments. We have angular misalignments, we have radial, and we have axial. So in other words, when you say misalignments, there's some difference or some discrepancies regarding the position. So for angular, example, this is our shaft 1 and this is our shaft 2. Then in terms of angle, there's actually a misalignments. So that misalignments is referred to as angular misalignments. For the radial, this is also known as parallel misalignments. That means that recall that for the term radial, basically it is a term that passes through the center of the shaft. Okay, so any for example, this is your shaft 1 and then this is your shaft number 2. So therefore, there's going to be radial misalignments. Okay, so this is our 1 and this is our 2, and if this cross mark does not coincide to each other, then that means there's a radial misalignments. For axial, you will see here that instead of having this position, you're actually offset to this direction. Okay, so axial, this will be the axial direction. Okay, so once we understand this different types of misalignments, then we can actually tell the difference between the different types of shaft couplings. There are actually so many types of couplings, and you can read that in BIAS. And some of the types are probably a flexible coupling or chain couplings, or we can have gear couplings or something like a coupling like this, but with flexible, something like a flexible material in order to accommodate some misalignments. Now, if you have like this, and let's say this is a bolt, so if you bolt this flange or this coupling, then of course what you get is a rigid joint. But if we have some material, flexible material in between, then somehow we know that it allows some degree or some small degree of misalignments. And for this type of couplings, I guess this has this provides a larger misalignment capacity compared to the other types. We have these chain couplings. But if we want a larger misalignments, if we want to accommodate larger misalignments larger compared to the ones available for the shaft couplings, then what we need is the universal joints. Right? So universal joints used when larger misalignments are required. So example of application is the PTO of the tractor. So we have here the PTO. Right? So how would you connect the PTO to the implement? Okay, so if I draw this one in side view, let's say this is my tractor. And let's say this is my PTO. But what if my shaft implement would be, the shaft of the implement would be somewhere right here, for example. Then of course there's a large misalignments in terms of the angle, and therefore what I need is a universal joint. Okay, so a universal joint is something like this, and you can see that you can have rotations in this axis as well as this axis, and there's also a lot of types for the universal joints. Okay, so we can have telescopic, so that allows for actual, let's say, accommodate actual misalignments. And here we have a double, something like a double joint, and we can also have single joint. Okay, now we're done, so we'll move on to the question and answer. This is a video for the review questions for the topic on mechanical fasteners. Alright, now let's start our review questions. Okay, number 211. It is a mechanical device that transmits rotational motion and power. The answer is shaft. Number 212. Which of the following affects the horsepower requirement of the shaft? Recall this equation for power, which is simply 2 pi n t. So this one is the torque. This one is the rotational speed, which can be also translated to the linear velocity or tangential velocity or the peripheral velocity. For example, this is our shaft, or any motion, let's say points or rigid bodies. Let's say it undergoes rotation, so we can have a rotational motion. Plus, we can also have the tangential motion. And the relationship, as I've always said, is V is equal to omega R. This one is the rotational speed in radians per second. Okay, so therefore the answer for 212 is all of the above. Number 213. A shaft with varying diameter along its length is called a step shaft. Recall that, for example, we have this shaft that has a varying diameter across the length, and then we have already discussed that the reason for stepping the shaft is that it can help in the positioning of the, let's say, the bearings or the pulleys, as well as to provide much area if you have higher torque. Let's say at this portion you have higher torque, then of course you have to provide a larger area. And if this one has only let's say a small amount of torque or torsional stress, then of course you can just provide a small amount of area. And that's the reason why we draw the torque diagram across the length. Next, number 214. A solid shaft delivers 1,000 inch-pound torque at 800 RPM. What shaft diameter would you recommend? Use design stress is 6,000 psi. Okay, so when we're dealing with the shaft, our working equation typically would be this: P is equal to 2 pi n t, and you can have the shear stress, which is the TR all over J, and we can also have this deflection in the angular direction, which is DL all over JG. Okay, so I'll try to use this. We'll try to use this equation. And recall that in the previous videos that we have already derived an expression something like this: 16t all over pi times this one. So we express J in terms of the diameter, and then we simplify the equation. We work the math, and then we come up into this expression that the diameter to the cube would be equal to 16t divided by pi times shear stress. Now this, of course, would work only for solid, okay, for solid shaft. The assumption for J is pi over d to the fourth all over 32. Okay, so if we apply this equation, that's 16 times inch-pound. That's our torque would be 1,000. So that's 1,000 inch-pound, and therefore the shear stress should be I guess this is the torsional shear stress. This one should be in PSI, in pounds per square inch. So therefore, this is 6,000 PSI. And this is equal to 1 inch. Okay, so the answer is letter Now let's move on to 215. For 215, a solid shaft in the oscillating beam favorable to reach height is 0.4 meter long. If the angular twist is 4 degrees and is stressed to 40 megapascals, compute the required shaft diameter. Use a modulus of rigidity of 83 gigapascals and a safety factor of 0.36. So since we have an angular twist, then of course that would relate to the angular deformation, which is simply TL over JG. And another work equation we have for the stress is just the shear stress. The torsional shear stress is equal to the torque times radius divided by J. Now if we check our data given, we have the length, right? So we have this length. So we have this length, and we also have this angular twist, and we also have the G, this modulus of rigidity. And what we don't have is the torque and also the radius. However, if we try to, I think we can use this equation and substitute it here, because we also have the shear stress, right? We have the shear stress, and that's 40 megapascals. Okay, so therefore, if I have to express this in terms of torque, then that's just T is equal to J times the shear stress all over R. And now we'll substitute this here. So therefore, we have J times the shear stress times the L all over J times all over JG, right, times what else, R. And since we have J in the numerator and J in the denominator, then we can simplify the expression into the shear stress times the length times the modulus of rigidity and the radius. Okay, the next is, since we have this, we have this one, we have the L, we have the G, then what we're actually solving is the R. And therefore, R is equal to the shear stress, torsional shear stress times L over G times the angular twist. But take note that this angular twist should be in radians. And so our theta is equal to 4 degrees times, let's convert that to radians, 2 pi radians all over 360 degrees. That's equal to 0.0698. Okay, so now let's substitute all the values. We have the shear stress of 40 megapascals. And take note that the megapascal is equal to, right, note that the megapascal is equal to Newton per mm squared. And therefore, I have to change the units to Newton and mm. Okay, so 40 megapascals times our length, that's 0.4 meters, which is equal to 400 mm, divided by 0.0698 times our modulus of rigidity. And note that the modulus of rigidity is given in gigapascals, and we have to convert that into megapascals. So which is just simply 83,000 megapascals. Okay, so you can cancel this, the megapascals, and what's left would be the unit of mm, unit of length. The answer is 2.76 mm. Okay, and we have, the problem asks us to solve for the diameter. So the diameter is equal to the diameter is simply equal to 2r, which is 5.52 mm. But the problem also gives us the safety factor, so we have to multiply this. So D should be 5.52 times the the safety factor of 3.6, and we get a value of 20 mm. So the answer for number 215 is 20 mm. That's letter C. That's letter C. Okay, now for number 216, what is the power the shaft can transmit in RPM? If its RPM is 200, so our working equation is P is equal to 2 pi NT. And by the way, this is the power equation for rotational motion. But if you want to know the power equation for linear, we have this force times velocity. And for rotational, we have 2 pi NT. Okay, so we have 2 pi and times our revolution, our RPM, which is 200 revolution per minute, and this is actually 2 pi per revolution. Okay, times, since our choices is in watts, then this should be in seconds. So times 1 minute all over 60 seconds. Okay, times our torque, right? But what is the torque? Now our torque, we don't have it yet, but we can solve it using our derived expression of something like this, right? So we have this d cubed is equal to 16t. So we need to solve for this torque. So torque is equal to pi times d cubed times the shear stress all over 16. And if you substitute all the values, what we get is 62.8 kilonewton meter. And therefore, if you substitute this, and of course you have to probably change this to Newton, then what you get is I guess 1316 kilowatts. Okay, so since this is kilowatts, then we don't need to convert this to Newton. The answer for 216 is letter C. Now for 217, a solid steel shaft of a microhauler is needed to deliver 2.5 kilowatts while rotating at 1,200 RPM. Find the torque and minimum diameter of the shaft if its allowable shear stress is 40 megapascals. Okay, so the working equation for this is P is equal to 2 pi NT, and also another one is the this derived equation d cubed is equal to 16t over pi, this one. So when you apply this equation, what you get here is letter A, and for 218 what you get is also letter A. Okay, next number 219. It is a machine element used to fasten shafts, pulleys, and gear hubs together. The answer is letter C, keys. Number 220. It is a groove that is placed on a shaft to prevent the pulley from slippage. That is QA. Number 221, in a design of drive shaft assembly, the weakest part should be, for example, this is our shaft, and we have here our, let's say, our pulley. So we need to provide key so that we can fasten the pulley into this shaft, right? So the problem says that which one should be the weakest? Is it the shaft? Is it the hub, or is it the key? Or is it the keyway? Or so we can have here keyway. Here we have the shaft. So the answer is it should be the key. 221. That the answer is letter C. Okay, why? So imagine if the weakest part is the shaft, then of course the entire assembly will fail. And if the hub is the weakest, then of course this pulley will fail. And therefore the answer is the key, because the key, if it fails, then it's just a small part, and therefore the cost of the damage would be less as compared to if the one that fails is the shaft itself or the hub. So the answer is letter C. Next number 222. Generally, what is the maximum length of keyway allowable based on the diameter of the shaft? Okay, so some rule of thumb is that if this is our cross section, okay, so if this diameter, or if this distance is D, which is just the diameter of the shaft, then our distance right here would be 1/8 of the diameter. And therefore our key right here, if we have a key, if we insert a key in this keyway, the key would be, right, the key would be 1/4 of the diameter. And in terms of the length, then the length of the keyway, that should be, the maximum should be 1.5 D. Now this is just something like a rule of thumb, but you can check the details. You can check the tables in PIAS if you'd like, and try to see that this value is actually is within the range. So somehow this would be a handy computations regarding the relationships between the diameter, the key, and the key length, or the length of the keyway. Okay, so again, if this is D, then the groove would be 1/8 of the diameter, and the key itself would be 1/4. All right, that's simply because you would want to insert something like this, right? So from this point to here, that's 1/8. So from this point to here to the top of the key, that's another 1/8, and therefore that is 1/4 of the diameter. And now, if in case that when you did the computations, the length of this keyway would require much longer length than this 1.5D, then in practice, or practically, what you can do is to provide maybe around here, so at the opposite side, or if it still requires much, then you just have to distribute the groove or the keyway. Okay, so 1.5D. So for number 222, generally, what is the maximum length of keyway allowable? That's 1.5D. This is letter A. Number 223, what is the recommended width of square key based on the diameter of the shaft? That's letter A. Number 224, what is the recommended depth of square key based on the shaft diameter? That's 1/8D. Then 225, what is the recommended key cross-section for the shaft below 5.5 inch? That's letter A, that's a square key. And if it's above 5.5 inches, then it's rectangular. So 226, that's letter B. Number 227, the shaft diameter of an auxiliary shaft is 30 mm. What size of square key based on the shaft diameter would you recommend? So 30 divided by 4, that's around 7.5. So this is letter B. 228, all rotating parts of agricultural machines as prescribed in the PAS should be dynamically balanced. Number 229, which of the following is a disadvantage of keyway? So A, it increases unbalance in the shaft. B, the shaft is weakened. This is actually true that the shaft is weakened because you have a groove or you have a hole, and that induces stress concentrations. Also, since you have a hole right here, and in this part probably, let's say you don't have a keyway, then of course you would have an unbalanced shaft. And letter C, alternating load give a play and risk of breakage and fatigue, of course. So the answer is letter D, all of the above. Next, 230, which of the following tools should be used for removing the hub from a shaft? The answer is puller, letter C. 231, which of the following is the reason why the pulley is difficult to remove from the shaft? The answer is all of the above. And 232, it is a machine element described as a series of axial keys machined into a shaft with corresponding grooves machined into the bore or the mating part. The answer is splines, letter B. Number 233, a device used to transmit power by connecting shafts together. That's coupling, so it can be flexible or rigid. So the answer is letter C. Number 234, it's a type of coupling that can accommodate almost no alignment. Actually, that should be almost no misalignments. Okay, so take note, just that should be misalignments. The answer is rigid coupling, letter A. Okay, letter A. Next number 235. If the type of coupling that offers, it is a type of couplings that offers the advantage of torsional vibration dampening, and they can accommodate large torque and small misalignments. That's jaw coupling, letter B. Number 236. It is a type of coupling used for large shafts over 2 inches in diameter, very high torques, and some accommodations for misalignments and rough applications. That's chain coupling, letter D. 237, which of the following couplings can accommodate very large angular misalignments? That's the universal joint. 238, a water pumping plant is designed to deliver water from a river to the farm. The river is 6 meters lower and 10 meters away from the farm. The pump needs to be installed at the midpoint between the river and the farm, while the engine is to be installed at the river bank. As an agricultural engineer, what drive system would you recommend in the design of the plant? That's universal joint, of course, because there's very large misalignments. Number 239, which of the following factors is considered in the selection of the coupling? Answer is all of the above. And number 240, a universal joint is used to transmit power between two intersecting shafts, especially when the angle between them is variable. So letter B. Okay, so that's all for these review questions in shafts. This is a video for the review questions for the topic on mechanical fasteners. Okay, so number 275, it is a fastener with head on one end of a shank or body and a threaded portion on the other end designated or designed to mate with a nut. The answer is bolt, letter B. 276, it is a fastener with head on one end of a shank body and threaded portion on the other end designed to be inserted into a top hole. The answer is machine screw. Number 277 is a fastener which is threaded in the entire length and the knot is used on both ends to create tensions, serving the function of a bolt. That's a stud bolt. And 278 is used to fasten machine threaded fasteners in through hole applications. That's letter D. Number 279, the diameter of a bolt is measured based on the shank diameter. So if this is our bolt, so this is the threaded portion, this is our bolt head, and then this is our shank. So for 279, the diameter of a bolt is measured based on the shank diameter. It's not the head diameter. It's not the threaded portion, because if you see or if we zoom in this one, what we see is something like this. So this is the thread, and when you say major diameter, I guess it refers to this one, and you have this another diameter at the root of this thread. So the basis for the bolt diameter is based on the shank. 280, the type of screw thread used for rotating machines, remember, such as impeller shafts. And we have a left-hand thread, that's letter B. Number 280, the 280 is letter B. This 279 is letter C. Okay, number 281, the type of screw thread used for almost all fastening applications, we have a right-hand thread. Number 282, bolt thread having a thread diameter less than the shank diameter. The answer is rolled thread. 283, a hexagonal bolt is the following designation: M10. We have M10 by 1.5 by 50, and we also have grade 5.8. So the problem or the question says, what does M10 refers to? So this M10, the letter M, that denotes metric size. So that denotes a 10 mm diameter bolt. Okay, so the answer is letter B. So this is metric designation for the nominal diameter. Number 284, what is the approximate tensile strength of the bolt? So we have here the grade. So we have 5.8. And by the way, you would also notice that in some of the bolt having these designations, sometimes they have this 8.8 or 12.6. And for some other standards, they use markings like this. So that's a different standards. But for this one, sometimes you would see that there's an 8.8 or 4.6 or something. So if it is 5.8, then that means so let's write it here. So if that's 5.8, the 5 that correspond to the approximate ultimate tensile strength. So that's our ultimate tensile strength, and recall that in the stress strain diagram, this refers to that point, the ultimate tensile strength, and this is our yield strength. And the 0.8, that's 80% of the 500, so that's 400, and that refers to the approximate yield strength of the bolt. So for 284, For 284, the answer is letter D. 285, the approximate yield strength is 400 megapascal. That's letter B. And 286, a bolt designated as M10 by 2. What is the pitch of the thread? So this is M10 by 2. Then this refers to the pitch, the thread pitch. This 86, the answer is 2 mm. The answer is letter D. 287, which of the following bolt thread series is appropriate for an oscillating sheave of a rice thresher? So sometimes we have these fine threads, and there are also threads like coarse threads. So if we have an application that's vibrating or in dynamic conditions, then what we want is a fine thread. The answer here is letter B. 288, the length of the bolt shall be 288, the length of the bolt shall be that blank. Okay, the answer is letter C. All the threads of the knot engage with 2 or 3 threads over. So for example, this is our plate. All right, this is our plate and this is our bolt. And we have to insert this bolt right here, right? And right here will be our knot. Okay, so how many threads over here would be, that's 2 to 3 threads over. So the answer is letter C. Number 289, it is an element used to spread the load over a greater surface area when tightening a bolt, screw, or knot. The answer is letter C, that's washer. 290, which of the following types of washer does not provide a locking mechanism? So other types of washers, we have these spring washers or lock washers that looks like this. Whereas some types, or the common ones, are just plain. It's just a plain, something like a disc. But this one, it has, it's something like a helix. Okay, so if you press this, if you tighten this, then somehow it pushes, or somehow there's some locking action that's being provided by this lock washer. For example, right here, if we put a washer, then of course, since this is something like, it acts like a spring. So if you tighten it, then you're inducing a force, something like this. But the washer induces an opposite force direction. So the answer for 290 is letter D. Okay, number 291, the answer is lock washer. That's letter B. 292, it is a headed pin of metal used for uniting 2 or more pieces by passing the shank through a hole. The answer is rivet. 292 is rivet. 293, a type of rivet used for fastening metal parts. That's blind rivet. And for 294, what size of rivet shall be used when the plate thickness is 1.5? And that's approximately the same as the plate thickness. So we can have 1.5 mm. 294 is 1.5 mm. That's letter B.
Okay, so that's all po sa natin sa machine design. Yung remaining questions natin, i-send ko na lang this week kay Ma'am Carol. Okay, you're welcome sa lahat.
Hello, sir. Thank you din, sir. Medyo maingay dito eh. Malakas ang ulan.
So, yung next natin, ma'am, is ano po, no, sa next week.
Yes, sir. Next weekend po ulit.
Sige, tapos afternoon.
Yes, sir. Same time
Okay.
po. 1.
Okay. Sige po.